Today we're going to be talking about congruence transformations. So congruence transformations are pretty simple, but I've given you just a little bit of notes and an example to help you guys out. When two figures are congruent, okay, that's what we're discussing. So two figures are congruent if and only if. What is if and only if? Exactly, makes it a biconditional statement. So two figures are congruent if and only if there is a sequence of one or more rigid motions that maps one figure onto the other. Okay. Because compositions of rigid motions take figures to congruent figures, they are also called congruence transformations. So that's what we're discussing, congruence transformations. Okay, what does this mean? Let's look at an example. Okay, in this example, it says, what pairs of figures in the grid here are congruent? For each pair, what is the congruence of rigid motions that maps one figure to the other? Okay, so this sounds crazy hard. It's really, really easy. So we need to find sequences of translations, rotations, and reflections that are going to take one shape to the next shape. So basically, here's a triangle, here's a triangle. What am I doing using translations, rotations, and reflections that will move one of these to the other? That's all we're talking about. Um, Actually, they look weird right now. 1, 2, 3, 4. 1, 2, 3, 4, 5. Looks like I shortchanged this one a little bit. So they're supposed to be identical, but of course I have drawn it, I think, too short. I think M is supposed to be here, and then it makes it work. So let's correct M before we continue on. Okay, this is why I like to do everything in pencil, because I totally make mistakes. So let's move M down here a little bit. So M should actually be here, I think. And then they should look much better. So let's see. Oh, yes, much better. Okay, fixed it. Now, this triangle and this triangle look alike. This trapezoid and this trapezoid look alike. And then, of course, our lines up 1 over 3, up 1 over 3, those are going to be moved. So we need to find sequence of translations, rotations, and reflections that map one figure to another. So let's look at triangle EDF, so EDF, and triangle MLN. Okay, so what looks like it has happened? Well, it looks like I rotated EDF 180 degrees. So from here to here is 90, from here to here is 180. So each one of our quadrants is 90 degrees. So I'm going to rotate it 180 degrees around the origin, and that's going to, now that I corrected my picture, give us triangles that are congruent. Let's look at what happens with the trapezoids. So first of all, there's a flip, and they've moved. So let's see, if I take this one over the y-axis, it now has the right direction. And then if I move it down, it will end up in this location. So I'm going to rotate it over the y-axis, and I'm going to translate it down 5 spaces and left 1. So left 1 and up 5. Oh, okay, I see what I did. I took this one to this one. So let's rethink. I'm going to move this one over here. All right, so I'm going to rotate it over the y-axis, and then I'm going to move it up. All right, so when I rotate it over the y-axis, my C will actually be at this location. But I don't want it to be at that location, because when you look here, it has to be on the y-axis. So I have to move it left 1 and up 1, 2, 3, 4, 5. All right, let's look at that again. I'm taking the trapezoid, A, B, C, J, and I'm trying to figure out how to make it trapezoid W, X, Y, Z. So the first thing I have to do is I have to reflect it over the y-axis. So I've got to flip it. When I do that, since it's 1 point away over here, it will be 1 point away over here. So I'm just looking at what's going to happen to C. C would be right here. But let's look at where Y is. Y is on the axis, which is going to cause me to make a movement on the x-axis left 1. So there is my movement on the x-axis left 1. Now I have to move it from this point up to where the Y is. So that would be 1, 2, 3, 4, 5. So I'm going to reflect it over the y-axis, and then I've got to translate it left 1 and up 5. When I do that, I'm going to get trapezoids A, B, C, J, and they're going to be it's going to be equal to W, X, Y, Z. Now, let's look at what happens with the line. With my line, I'm going to start with HG and try to get it up here at PQ, which means I've got to move H over 1, 2 spaces to the left, right there, and I've got to move it up 9 units. Then the line segments are going to be congruent. So this is kind of like a puzzle that you have to figure out where to move what to get them to be congruent to each other. Let's look at another example. In this case, I'm taking triangle JQV, and it is similar to, or it's congruent to triangle EWT. Okay, so here is JQV, and I'm going to end up here at EWT. All right, what is a congruence transformation that maps this to here? All righty? Okay, so you can see here with this triangle, I'm showing you the in-between step. I'm moving it first up. So I'm just going to translate it up. Just from where it is, I'm going to translate it up. And I'm going to translate it up 5 units because I can see that that will put this point here, and I will then be able to just reflect it over the y-axis to get the new triangle. So if I translate it 5 units up, that's what all of these steps are here. So I'm adding 5 to each x. So if j was originally 2, -1, sorry, j was originally 2, no, sorry, it's not j that I'm talking about. J is going to go up 1, 2, 3, 4, 5. Okay, I'm going to move it up 5. And then Q, I'm going to move it up 1, 2, 3, 4, 5. And then V, I'm going to move it up 1, 2, 3, 4, 5. And here are the new points when I move it up. Now, once I move it up, I'm looking at this triangle, and I need to get this triangle. So now, after I translated it over vector 5, 0 to get here, I've got to reflect it over the y-axis to get here. So down here at the bottom, you can see that when I take my J point, which is 2, 4, and reflect it over the y-axis, following the rules that I gave you for reflecting, this is going to just become, whereas it was 1 this way, I'm going to move it 1 this way. So our rule is we just count over the same way, or we can find the difference. If this one is 2 in this direction, we will now move 2 in this direction. So I will get the new points for each one of these, and I can say, finally, if I do the composition of the reflection over the y-axis and the translation of 5, of vector 5, 0, it's going to map triangle JQW onto triangle EWT. So look over this example again. Make sure you understand it. If you have any questions, just send me a message on Remind, or you can send a question in Google Classroom. But make sure you understand where my points are and look at the diagram to see what I did first. Remember, the inside step always occurs first. Let me move it up where I'm pointing. The inside step occurs first. The outer step of the composition is the second step. So let me know if you have any questions, and we'll see each other tomorrow.